Have you ever stopped to wonder how your computer can instantly sort your emails by date or your contacts by name? It's not magic, It's pure logic. Today, we're going to pull back the curtain on something called sorting algorithms. These are the hidden rules that computers use to turn a complete and total mess into a perfectly ordered list. So how do they actually do it? Well, let's break it down. Think about it. Every single time you sort a spreadsheet or look up a contact on your phone or see products listed from cheapest to most expensive, you're watching this exact process in action. It's really one of the most fundamental problems in all of computing. How do you take chaos and bring order to it? Okay, so let's get specific. Just look at this jumble of numbers. It's totally random. How does a machine, something that only understands very strict rules, turn this digital mess into a nice, neat line? Well, it turns out there's more than one way to tackle this, and each method has its own unique personality. First up, we've got a method you've probably used yourself without even thinking about it. We're going to call it the inserter, but its official name is insertion sort. Just imagine you're sorting a hand of playing cards, right? You pick up one card at a time, and you just slide it into its correct spot. It's simple, it's intuitive, and it's very, very methodical. All right, let's give it a try. The algorithm is going to build a sorted section piece by piece over on the left. To kick things off, it just looks at the first number, 18, and considers that its own tiny, already sorted list. Everything else is still just chaos. So now the algorithm looks at the very next number, 12. It asks, is 12 smaller than 18? Yep, it is. So it just shifts the 18 over and pops the 12 right in at the beginning. Just like that, our sorted section is now 12, 18. On to the next one, 16. The algorithm compares it to 18. Yep, it's smaller. Then it compares it to 12. Nope, it's bigger. So 16 gets slotted right in between them. You see the pattern here? One by one, we're building up this nice ordered list. And here comes a big move. The next number up is 2. The algorithm picks it up and has to compare it all the way down the line, past the 18, past the 16, and past the 12, until it finally finds its proper home right at the very beginning of the list. After the 3 and the 1 are also slotted into place in the same way, we have our final result, a perfectly sorted list. It's just like sorting those playing cards, right? It's a patient, one-at-a-time kind of process. So that was the inserter. But what if instead of carefully inserting things, we just swapped them around? That's the whole idea behind our next method, the bubbler, or as it's really known, bubble sort. This one works by repeatedly comparing two items that are right next to each other and swapping them if they're in the wrong order. With every pass, the largest values literally bubble up to the top. Let's watch it in action with this new list. Now, the goal here isn't to build a sorted list from the left. Instead, the goal of each full pass is to push the single largest unsorted number all the way to its correct spot on the right. Okay, watch this. First pass, 16 and 12 are compared and swapped. Then 16 and 46 are compared. No swap needed. Next, 46 and 27 get swapped. And finally, 46 and 23 are swapped. And with that last swap, the biggest number, 46, has bubbled all the way up to its final position at the very end. Now for pass number 2. The algorithm's actually smart enough to know that 46 is already sorted, so it just ignores it. It repeats the whole compare and swap thing, and this time the next largest number, 27, bubbles up and settles in right next to it. And this just keeps on going for a few more passes, with each one locking the next largest number in its place until, voila, the entire list is sorted. Now, it might seem a little clumsy with all that back and forth swapping, and yeah, it's often slower than other methods, but hey, it gets the job done. Okay, our final method is the most powerful of the three. It's known as merge sort, but we'll call it the divider. It uses a classic strategy actually borrowed from military tactics, divide and conquer. Instead of struggling with the whole list at once, it just breaks the problem down into tiny, super manageable pieces. To really see the power of this one, we're going to use a longer, more chaotic list. Now, you might expect it to start comparing numbers right away, but its first move is completely different and almost deceptively simple. Look at that. The algorithm doesn't sort anything. Not yet. It just splits the list right down the middle. That's it. Now we have two smaller problems to solve instead of one big one. And it doesn't stop there. It just keeps dividing and dividing and dividing until every single number is in its own list of 1. Now, why would it do that? Well, because a list with only one item is, by definition, already sorted. The divide phase is now complete. And now for the conquer part. The algorithm starts merging these tiny lists back together, but this is where the magic happens. To merge two of these small sorted lists, it just looks at the first number of each, picks the smaller one, and adds it to a new list. It just repeats that, always picking the smallest available number until the two little lists become one larger sorted list. It does this over and over until only two big sorted lists are left. And now for the grand finale. The algorithm merges these last two sorted lists. It just needs to walk down both of them at the same time, picking the smaller number each time to create the final perfectly ordered list. It's an incredibly efficient and, honestly, kind of beautiful solution.
So, there you have it. We've just seen 3 completely different ways to get to the exact same goal: the inserter, the bubbler, and the divider. Each one has its own logic, its own style. And this table really sums it up perfectly. Insertion sort is just like organizing cards in your hand. Bubble sort is like watching the biggest bubbles in a drink rise to the top. And merge sort is like a full-blown military operation. You know, breaking the enemy into smaller pieces before reassembling your forces for victory. 3 unique strategies, all hitting the same target. And each one is what we call an algorithm. Yeah, at their core, all 3 of these methods are algorithms. The best way to think of them is like recipes, just a finite set of rules for solving a specific problem. From your social media feed to your GPS, these kinds of recipes are the fundamental building blocks of our entire digital world. And that really brings us to the crucial point here. Even for a task as simple as sorting some numbers, there's no single right answer. There are multiple paths to get to the solution, and programmers have to choose between them, making trade-offs between elegance, how much memory it uses, and, most importantly, speed. So that leaves us with one final thought. If this much intricate logic is happening behind the scenes just to sort a simple list of numbers, what other invisible, incredibly powerful algorithms are quietly organizing the information you see every single day, shaping your entire experience of the digital world?